Okay, so let's just review some things here. The fundamental theorem of algebra. So, Kelly, why don't you tell me what this is and put it in your own words. What is the fundamental theorem of algebra? It's just plain vanilla and plain words. What does it say?
That every function has to have at least one zero.
What do you think, Ben? The fundamental theorem of algebra says that for every polynomial, whatever your degree is of that polynomial, there's exactly that number of zeros.
Oh. Well, why
They
does it
aren't
say
all,
at least one?
they aren't real. It's at least one for every degree. So for every degree n, okay? So if you have a third degree polynomial, there's 3 zeros. If it's x to the 8th and you have an 8th degree polynomial, there's 8 zeros. Not all of the zeros have to be real. Some can be imaginary. Okay? But there's at least the same number of complex zeros that you have that'll be equal to your degree. Okay, that's all that says. Furthermore, the linear factorization theorem says that if you have a polynomial with a degree higher than 0, meaning it's not a constant function, it has a variable, if it has a positive degree, then it has exactly that number of linear factors. So for every 0, there's a factor. And a factor is just one of these x minus and then some number, some complex number. Now remember that the real numbers are all complex numbers, because any real number, for example, the real number 3 could be written as 3 plus 0i, which would just be 3. So all real numbers are complex. Okay? All right, so let us look at this. So you're going to want to grab out some paper or something to write with. So we have the function f of x equals x squared minus 8x plus 16. How many zeros are there, Kelly?
2,
There's 2. What are they?
4, and 4.
X minus 4.
Oh, did you want me to?
X minus 4. And so they are x equals 4 and x equals 4. So you have x equals 4, multiplicity 2. Multiplicity just means you have an equal, they're the same. You have a 0 that's more than one the same. And what does that tell you when you have multiplicity? If you have 2 roots and they're 2 zeros that are the same, you have multiplicity. What else does that tell you? What does it tell you about the graph?
So we're going to cross 1.
It doesn't cross at all. It lies on the axis, right? So you're going to get something that looks like this, and it's going to lie on the axis. If it crosses the axis, then you would have 2 different roots. So because it's the same, that tells you it lies on the graph. That graph touches the x-axis. Okay? All right, let's look at this one. Here's our function. X cubed plus 9x. How many zeros are there, Ben? How many zeros are there going to be? 3, because it's a third degree polynomial. So what are they? Well, that's what we're doing here. So let's figure this out. So how many do we have? What's the first thing we're going to do?
We did this yesterday.
We didn't do this particular problem, did we?
Yeah, we did.
I think
I
we.
have it written down.
Yeah, we did.
Okay,
Is
well, maybe I
that
did on the
the
board.
zeros were 0,
Okay.
3i, and negative 3i.
So this we're just reviewing then. So x plus 9, and so then you had what? X plus 3i, x minus 3i.
Yeah, I remember that.
Okay, and so x equals 0, x equals minus 3i, and x equals 3i. Okay?
Yep, and we
And if you don't
were-
immediately notice that you can factor this 9 into plus 3i minus 3i, you could have used the quadratic formula. I think we did that yesterday, right? We used the quadratic formula to find the 3i. All right, then this one is the one where we left off on then, is this last thing here. Well, actually, I think we were, yes, this is the one we left off on.
Yeah.
Okay. So, we have this function, f of x equals x to the 5th plus x cubed plus 2x squared minus 12x plus 8. All right? And so we want to know how many zeros are there, first of all. So how many zeros will there be, Kelly?
5.
There'll be 5. And so it wants us to find the 5 zeros. Okay? So it wants a complete factorization. So How are we going to do that? Ben, what's the first thing we're going to do? Because you see this thing x to the fifth. What?
You do the Q over, is it Q over P or P over Q?
P over Q, which is
The 8.
plus or all the factors of 8, plus or minus 1, plus or minus 2,
Yeah.
plus or minus 4, plus or minus 8, all over the leading coefficient, which is plus or minus 1. And so then we do some synthetic division, right? Now, to save ourselves a little bit of time, I could do this without using a graphing calculator at all, because I could put every single one of those numbers in, and I could find where I have a remainder of 0, and that would give me my real roots. I'm sorry, my rational roots, not my roots, my rational roots. Or, and I could do that. And I could do that with 8 different numbers. I could do plus 1, minus 1, plus 2, minus 2, plus 4, minus 4, plus 8, minus 4. But if I want to save a little bit of time, put this into your graphing calculator and see if that gives you a hint. See if you can see where you think the zeros might be, where the rational zeros might be. And all that will do is save you a little bit of time. We'll still use the synthetic division to check those, but that will save you from actually having to do 8 different synthetic divisions. But keep in mind that if you didn't have a graphing calculator, you could do that by doing all 8, and then you just eliminate some. So put that on your graphing calculator and see what that looks like. Now, when I do my synthetic division,
So wait, it can have 5 zeros, or it does have 5 zeros?
it definitely has at least 5
Real.
complex zeros. They aren't all real. No, they don't have to all be real. You can have up to 5 real. I'm guessing this won't. So when you put
Right,
this
so
on
you
graph,
have up to 5, you don't have exactly 5.
you have exactly 5 complex. So you take the real ones and then subtract that out from your degree, and that'll tell you how many complex ones you have to have.
Whoa.
How many imaginary ones, I should say, not complex, because real numbers aren't complex.
So there's going to be 3.
There's going to be, you got 3 real zeros on your graph? I don't know. Let me see what the graph looks like.
2. 2.
Oh, actually you do have 3, don't you?
What? No. Oh, wait, yeah, because that rests at the points.
And you have a multiplicity of 2, right? If it rests on the x-axis?
Yep, you're right.
Okay. Does that make sense to you, Kelly?
Yeah.
All right.
it's
So remember when we're doing our synthetic division that we don't have an x to the 4th there, so we've got to remember to put in our 0 for that. 1, 2, minus 12, and 8. Okay. So what zeros out of those possibilities do we think is definitely going to be a 0? 2?
Yeah.
All right. So 2 times 1 is 2. 2 times 2 is 4. 12 times 2 is 24.
Just kidding, it's not.
What?
It's not, is it?
2 times 24. So was 2, did 2 look like a line on the graph?
They're -2.
Oh, so -2. All right, so well, that's a good way. So now you know if you'd have done that on synthetic, you would have known 2 is not a root. So it doesn't cross the point x, 2, 0. 2 wasn't a root, right?
I'm not so
So it looks like from your graph that -2 will probably be a root, though. 1, 2, 8. All right, so 1 times -2 is -2. -2 times -2 is 4. -2 times 5 is -10. -2 times 8 is -16. Minus 20. Did I? -2
It's stupid.
minus
It's
2 is 4.
4.
5. -10. Oh, did you get
-12 minus 16 is 4, not 2.
-12 minus 16 would be -28, wouldn't
Oh.
it? -2, that's a positive 8. 8 plus 2 is 16. Oh, that's a positive 6. No, that's a -16. 28.
Yeah, no, it's going to be a positive 16 because it's -10
Huh?
plus 2.
2 minus 10 is -8.
Ah, there was my negative there. So that's a positive 16. That gives us
Positive
4.
4, -8, 0.
-8, 0. Good. So what does that tell us? That just tells us that x plus 2 is a factor, right? Okay, so we have a factor at x plus 2. Now what? What's our then from your graph, you had some more, right? You had one more that you should have a multiplicity of.
1.
1.
The number's 1.
Mhm.
1 times 1 is 1. 1 times 1 is 1. 1 times 2 is 2. 4 times 1 is 4. Minus 8 times 1 is minus 8, which gives us 0. Okay, so that tells me I have a multiplicity at x minus 1. Okay, and we know it lies on the graph, so there's going to be another one as well. But well, let's test that. So where's our, does someone have this polynomial written down? Just write it down real quick so when I scroll you can read it to me and I don't have to write it. You got it written down? Oh. All right. So notice something. So I have a factor here of x plus 2 and now a factor of x minus 1.
Squared.
Huh?
Squared.
Well, what did this tell me? This told me one of the quotients of my polynomial up here. So I know that one of my factors would be x to the 4th minus 2x cubed plus 5x squared minus 8x minus 4?
Yeah.
Or was that positive? Was that a positive or minus 4? I just crossed off, so I wasn't sure. That was a positive 4. They way out was positive. Okay. So, if I take my x minus 1, which I know is a factor, and I put it into that new quotient of 1 minus 2, 5 minus 8, and 4, what do I get?
Where's the remainder?
What's that?
Oh, no, there's not. What? I don't want
Is that what you got?
it. No.
Well, do you see where you find out where you make your mistake? Just look at it and see, you can see which number you do. Okay. Okay. And what polynomial does this give you, Kelly? We started with this one, and x minus 1 was a factor.
Cubed minus x squared.
That one there. And so that was with x plus 2 and x minus 1. And then, now we think that there's a multiplicity of 2 from our graph, so we'll throw another x minus 1 into this, because we think there's 2 of them. We just did one. We just did one of them, now we're going to do another one. So we have 1 minus 1, 4 minus 4.
So if you didn't know, you'd have to guess which one is the multiplicity. Like if you didn't know that.
If you didn't know, you'd have to put them all in based on that P over Q. You'd have to put all of them in and try all the synthetic division. So if you didn't have the graph, you'd have to try all. So you could do this, that's why I'm saying without the graph. I'm just doing it so we get less time in class. So looking at the graph, you get an idea of what they are. But if you didn't have the calculator, you could put all of them in and just do it this way. So what are we going to get? Well, we're going to do 1 times 1 is 1, 0, 0, 4, plus 4, 0, right? So that confirms that we have another x minus 1 because it came out to 0. So far we have an x minus 1, an x minus 1, and an x plus 2. All right, and what does that leave us with? X squared, and you could say plus 0x, but let's leave that off, right? Plus 4.
Oh.
That's all we have left, right? And now at this point, you don't need to do any more synthetic division because how do we factor this?
X
How?
minus 2i x
Plus 2i, right. And if you couldn't see that automatically, then you'd have to use the quadratic formula. But yeah, x plus 2i, x minus 2i. And then x plus 2, x minus 1, x minus 1.
And
So that's your complete linear factorization. So you could factor the whole thing out. So notice that was a 5th degree polynomial. There's your 5 zeros. 3 are real. 2 are complex. These are complex, 5 complex, because these are complex too, but these are have an imaginary part.
Majorly complex.
They have an imaginary part. So to see how we got that? Does that make sense? Okay, good. The next part says complex zeros occur in conjugate pairs. Okay? So if f of x is a polynomial function that has real coefficients, a plus bi, b is not equal to 0. So if b was equal to 0, all you'd have was a real number, and so so this doesn't affect that. So if b is not 0, if you have a complex number where you have an imaginary part, then the conjugate a minus bi is also a 0 of the function. So in other words, if a plus bi is one of the factors, then a minus bi also has to be a factor. So they have to come in conjugate pairs. All right, so we're going to use that fact to do this. Find a polynomial function. So we want to find a function with real coefficients that has the given zeros. So how many zeros? First of all, what degree? It says find a polynomial. What degree polynomial am I going to have?
5.
5. Why 5?
Because you also have to have 1 minus root 2.
You have to have, right. You have another 1
Oh, 1 minus.
Why does it deceive me?
of
though?
minus
Root
1 minus radical 2i. You have to have the conjugate. Well, that's what you just said, right? If you know you have this, they have to come in conjugate pairs, which means you have another root that's the conjugate of this.
Yeah, so then it's just 1 minus root 2i.
That's what I wrote.
Really put the negative.
What? The negative is because it's minus.
Yeah,
Well, it says a random
but
plus.
just never mind.
Does that make sense?
Yeah, just,
Did it confuse when I put the positive up here?
Yep.
Just so you know that this is positive, not negative, because sometimes when you do the conjugates, you're thinking that you need to negative it up.
No.
The negative only
I
goes
would
in
not
between.
have thought that, so.
All right, so that's why I just put a positive, just to be clear.
Don't do that.
All right, so now what? So how would I find, now how would I find it?
X minus
What's-
0, x plus 0.
What's, okay, good. X,
Am I right?
you're doing, do the linear factorization. X minus 0, x minus 0,
X
X.
plus 0. That's just going to bother me if it's 2. I don't know. I don't
But it's not because they're both 0.
Okay, yeah, I guess I'll
right?
X minus 1.
X minus what?
1.
One
Oh,
plus
1.
one.
Yeah, 1
There's
plus
a bracket there. 1 plus 2i, and then x. Oh, did I hit the one? One of these brackets, what I had. Okay. X. Well, because we have 2 sets of grouping, I just
You
keep
don't
it
need
clear.
the parentheses there.
Well, because you're
In front of the
You're
X,
subtracting
no.
x minus square root of 2i.
But you already had the bracket, so you didn't need the other parentheses in front of the X.
This parentheses group here takes this bracket.
No, and the second one, you have bracket, parenthesis X minus parenthesis 1, no, the one after that.
Right, then I run another bracket like that, right?
Yeah, but you don't need the first parenthesis in front of that X.
Oh, I'm sorry. I got you. All right.
It was just gonna confuse.
So now what though? All right, so now we got our linear factorization, at least hopefully in a readable form. So now what?
Right.
No, how am I going to find a polynomial? The hard work is,
You do the distributing and foiling.
X.
okay, you're going to multiply everything. You have 5 factors, you're going to multiply 5 things together. Well, so there's several different ways to do this because again, one of the nice things about math at this level is there's an infinite number of ways to do some of these problems. So for example, I could multiply this times this, and then I can multiply this times this, and then multiply them together, and then multiply the whole thing by this. But what I want to try to steer you in is look at this sort of intuitively and think, what are the easiest things to multiply? What's going to be the easiest way? Because I can do the math, and I can have 1,000,000 steps, or I can have 10 steps. So,
Let's do the last one.
well, what is x minus 0?
X squared.
X minus 0 is x squared?
X.
It's just x. And x minus 4.
Well, it's going to end up equaling x squared.
Well,
Because x times x is x squared. Is that bad? I shouldn't do that?
no, I like to separate it into my real and my imaginary parts What's x squared times x minus 4?
Cube.
X cubed.
X squared.
Alright, so I'm going to have that multiplied by, then I'm going to multiply these together, and then multiply those, that times this.
Oh, this is fun.
Well, it's just math at this point, right? Just multiplying.
Yeah, that's why it's fun. It actually makes sense. Now.
So, what are you doing? What do we got going?
Now here.
It's gonna be x squared.
What's that?
X squared something?
Well, you're just foiling, you get just foiling, right? But you notice you got 6 terms. You see that you have 6 terms? 1, 2, 3, 4, 5, 6. So you're distributing 3 times, x times those 3. Let me use some different colors and it might, x, x, x. And then
Oh.
negative 1, negative 1, negative 1. And then another, what do I get rid of? Black. And then
Whoa.
hopefully yours is neater on your paper. You can
What is
read.
negative?
What's that?
Never mind. I'm just gonna
So
look up
I
confusing.
have x squared minus x minus x square root of 2i minus x plus 1 plus square root of 2i plus x square root of 2i minus square root of 2i minus 2i squared. I wrote it, couldn't write it all in one line just because it's of the size there. But those should be your 9 terms, so make sure that you have those correct before we move on.
Oh boy, this is gonna be fun.
It's just adding I mean, there's a lot of parts, but they're all easy to multiply. You just gotta be careful with your signs and be careful with how you're doing it. But then some neat things will happen after you're all done.
Oh, this is awesome.
Okay, getting it?
Mm-hmm. Okay. Cancel. X squared minus. Yeah!
Did you get what I got?
Oh, I went farther.
Oh, wonderful.
Well, I tried. I got that far, yes.
You did, you got this, okay.
Wait,
Are you still working on this
I
part,
didn't.
Kelly, or are you? I want to go ahead. Is this what you got?
Oh.
You multiplied all these things, you got 9 different terms, right?
Yeah, but I got.
And then you started combining already?
Ooh. There's my
I have
problem.
something different. Hold on.
So just
It
look at the one you did
is,
different, and then we can.
Oh, because square root 2i times square root 2i is going to be a minus 2i squared because the square root times square root is the inside of it.
Correct.
Okay. I see my
I
problem.
don't
Is that the
know. I
only-
got a whole answer is x squared plus 3.
Is it
No,
x
missing
squared
the
minus
2x.
2?
You're
X
missing your
squared
x
minus
minus
x
x.
minus 2?
It's,
But,
well, look, once you get to this point, I want to make sure you can get to this point.
I did.
Alright, so once you get to this point, notice that you have a couple things. Minus 2xi and plus 2 square root of xi. So that's just a cancellation. Then you have minus 2i plus 2i. That's cancellation. And so really, what do you have left? You have x squared minus 2x.
What?
You have a minus x minus an x.
Where is there 2x?
Well, that's why I said you got to have all the terms. That you've got all your terms.
Oh, I messed up.
That's.
Oh, I thought you said it was minus
Still.
1.
I'm not
Can
done
you
yet. I'm just
like
showing you.
rewrite this out on the whiteboard so that it makes more sense if it's all online?
It was x minus 1 plus square root of 2i times
This is man.
x minus square root of 2i That's all right. No, I understand. I want you to be able to see it.
I'm gonna redo this. No.
So now when you FOIL, x squared.
Wait, no, 1.
What?
You have something wrong. It's that the x minus 2i, that's supposed to be a 1.
What?
Oh, I have another x there. I copied that.
Oh.
Good, thank you. Okay, so x squared minus x square root of 2i minus x plus 1 plus square root of 2i minus square root of 2i minus 2i squared. That's what I have up on the board.
Okay.
It is easier if you can write all in one. On my notebook paper, I wrote it all in one. It's the smart board, I can't. I write too big to be able to fit that all in one line.
X squared minus 2x plus 3.
Hold on a second.
I think I got it. Let me see what you're missing.
I just had a. I was confused how if I squeeze it up in here, but it was my plus.
You're missing a plus 2i.
Square root of 2i, right?
Square root of 2i, yeah.
It's just in between there.
Yeah.
So
Oh no, it's in between the.
it doesn't really matter. They're gonna cancel out.
Yeah, it's gonna.
That's the bottom
It's
line.
gonna
That
go
cancels
bye bye. It's
It
okay.
does, it goes bye-bye. And so that's all you're left with is,
We're still, I skipped ahead, sorry.
so we still had, so we this and then it was, because you have a negative 2i squared, that's just a plus 2.
Yep.
Okay.
I got
Those
that.
canceling.
Plus 2.
And you forgot a plus 1 down there. Because the answer comes to x squared minus 2x plus 3, right?
Oh, well.
And there's the 1 up there, plus 1.
Yep.
So x squared minus 2x plus 3.
Yep.
Okay,
Exactly.
so everyone got there?
That's. There's.
Now the
But then you gotta.
Well, then, yeah, now you got your real and your complex part. So x cubed minus 4x squared
Times x
times x squared minus 2x plus 3. And now it was just a simple,
Oh, this is awesome.
x to the 5th minus 2x to the 4th plus 3x cubed minus 4x to the 4th plus 8x cubed minus 12x squared. And then when we combine,
Alright, I got x to the 5th minus 2x to the 4th plus 11x cubed minus 12x squared.
was that what I had done on the bottom in black?
How did I run that? Oh, I see what I did.
I know there's a lot of spots. That's why you want to make sure you show your work. There's a lot of spots there where you can make mistakes because there's a lot of minuses and pluses, and you got to copy everything down perfectly. And if you make one mistake, then you went through 10 minutes of this problem and get to
Okay.
something totally different, right?
I like this math. This is actually.
Okay. So you agree with me here?
Yep.
And Kelly, are you there yet? Or
Oh, wait, no.
Because if you're still working on it,
11x cubed. 11x cubed.
Yes, but, yes.
did I miss it?
Is that supposed to be 11x cubed?
Yes, it is. I just did.
Okay.
Yeah.
See, there's a lot of rules. Okay, so everyone's there. Now, is this the answer to my question? My question was, find a polynomial function where those are the real coefficients. So is this my polynomial function?
Should be.
Now, is that my only answer? Is that my only polynomial?
Most likely not. Because it's math.
No, only because of this. This is a correct answer, but there's an infinite number of correct answers. And the reason why is because we learned any polynomial can be multiplied by any coefficient, which we call a. So if I put in a 1, so if I put in a 1, that's my thing. But if I put in 2, I can have 2x minus 12, or 3, or 4, or a half. So any of those polynomials will give me the same zeros.
Just have it in simplest. Like.
Yeah, this is the simplest one, but what I'm trying to say is that if you're just looking for a polynomial, any polynomial,
Yeah.
this number times any constant will still give you the same zeros.
Mm-hmm.
Okay. It will change your graph. So as I go higher, my things will loop higher and higher and higher, and they'll stretch, but I'll still cross the x-axis at the same points. Okay. Factors of a polynomial. Every polynomial of degree n, so a polynomial is just basically this. Well, they keep doing this, of degree n greater than 0. All they're saying is it can't be a constant function. You have to have a variable. Okay, it's got to have at least a degree of 1. It has to have a variable and an x in it. With real coefficients can be written as the product of linear and quadratic factors with real coefficients, where the quadratic factors have no real zeros. All right, here's the idea. A quadratic factor with no real zeros is said to be prime or irreducible over the reals. And these are just things from your sheets to fill out. So in other words, up here, where I have my 5 factors, if I took this and multiplied this together, I come down to this, correct?
Yep.
You have that written, right?
Yep.
So tell me what that is.
What do you mean?
Just read it to me, whatever it was I said. Get it.
Oh, x squared minus 2x plus 3.
This is said to be irreducible over the reals. In other words, you can't reduce that any farther down with real numbers. In order to reduce this down into more factors, you have to use imaginary numbers. Those are the i's that we use, okay? That's all it's saying. So, if I wanted to reduce this over the reals, I can have my x. What was my fourth factor? X minus 4, was it? Times this. So if they ask you, if they gave you this polynomial, if they give you this polynomial right here, oh, not that one, sorry.
You mean the finished
If
one?
they give you this one, yeah, the finished one down here, if they say, reduce this to linear factors over the reals, then this is what you're going to get. Because these are your reals, and then this is as much as the only real numbers you can reduce this down to.
So
In other words, they don't want complex numbers. That's what they're saying. If we want it irreducible over the reals, we don't want to add our
So
imaginary parts.
our goal is to get a polynomial to that and then be able to put that to a polynomial with only the...
If that's what they ask for. Here it says, give the factorization that is irreducible over the reals, and that's this. If I wanted the complete linear factorization, it would be just what I had. X times x minus 4 times, and then whatever my 2 other things were up there that we had. That was 1 minus square root of 2i, 1 plus square root of 2i. That would be a complete factorization. A complete factorization, according to the fundamental theorem of algebra, has 5 roots, or 5 zeros.
Okay.
We sometimes call them roots, 5 zeros. But if I want the complete linear factorization that is irreducible over the reals, then I'm going to want these 4 things. Okay? Does that make sense? That's all they're saying. So when you see these in the directions of these homework problems, they're going to say things like irreducible over the reals. That's all they're saying is, don't give us imaginary numbers. Take your imaginary numbers and turn them into real numbers. Okay, we only want real factors. That's what they're saying. Any questions on that? That's the end of the section. There's nothing